welcome to the Uncharted Applications of MPC panel. The world's tired of hearing about MPC for sugar beet auctions, so we're here to explore the edge of new applications that are in progress or on the horizon with an amazing and experienced group of panelists from industry, academia, and research. I'm Jordan Brandt, a board member at the MPC Alliance and co-founder and CEO at Infer, enabling privacy-preserving machine learning and analytics at scale. Sanjay Saravanan leads a cryptography-focused research team at Meta that collaborates across industry groups and standards organizations to co-develop privacy-focused solutions for the advertising ecosystem. Dan Bonet is a professor of computer science at Stanford University and has been working on real-world cryptography for 30 years. He's the real OG. More recently, he's been working on new cryptographic systems to support blockchain applications. Mariana Rykova is a research scientist at Google working on cryptographic techniques for privacy-preserving computation and applications. Mark Craddock led the development of the United Nations Global Platform, a multi-cloud platform for capacity building within the National Statistics Office and the use of big data and its integration with government data sources. Kurt Nielsen is a co-founder of Partisia Blockchain, and Sepure, and has been pioneering commercial use of MPC since 2008 across a variety of use cases and platforms. So thank you all for joining. It's great to have you here. And we just heard a great keynote from Josh Barron, who's a program manager at DARPA. And notably, he stated that from his experience, the least complicated solutions get transitioned into real world applications. And to paraphrase him, if the cryptography is too complicated, it's difficult to deploy. The hard work is in the deployment plus legal and policy requirements. So I think this is a great place to kick it off. Sanjay, in your experience, do you agree with the statement? What new applications for MPC do you believe that have or will gain a broad adoption?
Thank you, Jordan. I completely agree with here. I remember hearing in one of the past conferences where someone said, privacy technology or MPC should be almost like an invisible layer, like a foundational layer that powers product capabilities. So, and for something to be an invisible layer, it has to be standardized as much as possible, super easy to implement and operate and integrate. And you don't need to be, you shouldn't have to hire cryptographers to, build and integrate into these solutions. So from a simplicity perspective, completely agree with the statement. And in terms of what we're doing here, we still have a lot of work as an MPC community to actually get to that place. My team, for example, has predominantly been involved in working with a handful of companies across the ecosystem to build some solutions. So in terms of applications, we're part of an effort led by this trade group called the World Federation of Advertisers. And the focus there is to measure how well media works across platforms. So TV, digital, mobile apps, browsers, etc. And given the number of players involved in the space, we arrived at MPC as the right technology to use here, and we're hoping the solution is going to launch sometime next year and likely going to be one of the largest deployments at scale in the advertising space. Another example is our work with Mozilla to propose a new web platform standard. This is again in the advertising space to enable performance measurement within digital advertising, and here MPC was the right choice given the trust model that we have to enforce, as well as to enable, I think, interoperability. So having something that can work across multiple platforms and apps.
Great, thanks, Sanjay. We all look forward to the launch of this platform next year. It's been highly anticipated, so good luck on that. Dan, you've been working on cool stuff for a long time. What's new?
Yeah, thanks, Jordan. Yeah, I'll build on what Sanjay said. So there are obviously lots of application areas for MPC. There are clearly applications in the area of machine learning where we want to learn from multiple data sources. We're going to talk about that later in the panel. Actually, I wanted to focus on two applications that I find very interesting. One is in the medical space, and there's been many applications of MPC in the medical space. I'll give something that's close to my heart, which is one of our results, which is basically finding places in the DNA that cause particular disorders. And so this is actually work that we did with Gail Belgiano in biology and with David Wu, that basically is able to make it so that people who have the disorder can share their DNA without actually revealing what their DNA is, we run an MPC across multiple servers on thousands of people's DNA, and lo and behold, the researchers will find exactly the location in the genome that causes that disorder. And this is not science fiction. This is actually literally working, and it actually works quite well. And it actually finds disorders without revealing people's DNA to people's genomes to the researchers. I'm sure we're going to see tons and tons of applications like this in the medical space. So this is a very productive area for MPC. The other example application I wanted to just very briefly mention is something called collaborative proofs. This is recent work with Alex Ozdemir. And here the issue is that in recent years, there's been a resurgence in the need for zero-knowledge proofs. Those are proofs that allow you to prove that you know a certain witness that satisfies a certain property without revealing what the witness is. These enable a host of new applications. So these have become sort of a bedrock for lots of new applications of cryptography. What's interesting is traditional zero-knowledge proofs assumes that the witness is only known to one entity. What do you do when the witness is distributed across multiple entities? Think of the financial transaction graph, where banks, actually every bank will see one sliver of the global financial transaction graph, and somehow the banks want to work together and prove a certain property about this graph, but they don't want to reveal to each other what the graph is. And so we would like to build zero-knowledge proofs that work when the witness is distributed across many multiple entities. And it turns out MPC is a wonderful tool for this. So basically, the idea is basically to run the prover inside of an MPC and generate a zero-knowledge proof like that. The one last sentence I'll say about this is a very unusual situation where MPC basically comes for free. So generating these zero-knowledge proofs, these snark proofs, is actually so computationally intensive that the overhead of MPC almost adds nothing to the computation. So it's a very unusual situation where you can run a large computation in MPC, and the overhead over just doing it on a single server is not that much bigger.
Thank you, and that's great that you kind of flipped the dynamic in that scenario of the application with MPC and relative overhead. And yeah, thank you for continued contributions in MPC and cryptography in general. We're all leveraging a lot of your innovations that come out of Stanford. Mariana, obviously at Google, you guys have a lot of niches going on. Would love to hear more insight on what you think are some of the new applications.
Thank you, Jordan. I think I'm going to pick on several points that Dan brought up. I think the first one is maybe related to using MPC to help the health system. We had a very exciting collaboration in the last couple of years between Google and Apple, in which we tried to provide private analytics for the state health authorities in order to understand the effectiveness of the exposure notifications, which was a digital solution that Apple and Google developed jointly in order to help users detect whether they have been exposed to the COVID-19 virus. So this was one of the largest MPC deployments that I'm aware of, which actually leveraged some of the work of Dan. And we managed to provide this private analytics that was used, for example, by Washington State to evaluate how many human lives were saved and how many infections were avoided because of this application. And I think this type of application is part of a much more broader set of applications where we want to perform some type of measurement over user data that comes from millions of devices. And we want to do this in a privacy-preserving manner. And this is often phrased in the setting of federated learning, where federated learning usually focuses on the question of how do we learn machine learning models over the distributed data of many users without ever putting this data in the same location. So federated learning leverages techniques such as secure aggregation that enable these properties. I think secure aggregation often focuses on the scenario where we have a single server. I think there is a broad space for kind of introducing maybe a secure computation layer that can perform these properties, where the right type of architecture might depend on the different applications and also on the complexity of the actual measurement techniques we want to implement. So I, in some sense, view our work with on the exposure notifications private analytics as a different type of instantiation of what can a federated learning model look like. And also I would point out that if we squint the right way, when we think about federated learning and we are concerned about the accuracy of the input data that comes from the clients, we are effectively in a setting where we want to have a distributed prover, where the witness might be effectively distributed across all of the clients, and you might want to prove a property of the data that is coming from all of these many users. And that is, in this case, you cannot just take a zero knowledge proof and just plug it in. You have to make it work together with the MPC protocol that is already implementing the measurement or whatever other functionality you have. So I think these are all like areas with a lot of potential.
That's a great point. I think it's important for the audience to understand that MPC does work in concert with or complementary to other techniques like FL and ZK proofs, right? It's not one silver bullet for all problems. Absolutely. So Mark, you've done some cool work with the UN. Would you like to share more about what you guys see coming on the horizon?
Yeah, so we used a lot of privacy enhancing techniques at the UN. We actually published a book on it, which was several contributors from the MPC Alliance. And I think from my point of view, we see kind of MPC and the other techniques, they're kind of where they are in their evolutionary state. So all technology evolves from kind of genesis through to a commodity. And we use the technique of Wardley mapping. So this helps you understand technology where it is in its kind of phase of development. So we've seen MPC evolve from kind of the universities, those kind of development projects. The very handful of people actually coding and codifying kind of MPC. And over the last few years, we've seen it move into kind of products, and now we're seeing kind of services evolve. Yeah. So if you use the technique of Wardley mapping, you can understand this. You can understand how technology evolves, and you can see that kind of path of technology moving from the genesis phase, kind of new and novel, through to that kind of commodity phase. And and I guess it's moving as expected. It can be frustrating. It never seems to move quick enough. But this evolution can take 10, 20, 30, 40 years. So what we did at the UN, we produced a handbook on privacy enhancing techniques, to help to encourage that development and kind of move it faster and kind of move it forward quicker. Because across the UN, getting data from many different sources and using that to analyze it and producing kind of outputs is kind of what you need, especially when you got across countries, across borders, across boundaries, different legislation. Using these kind of techniques is kind of, I guess, is the ultimate way of collecting data in a safe way and doing those kind of secure computations on them to produce kind of statistics as it was at the UN. And I think it's kind of evolving where it should be. So if you use Wardley maps, you look at the kind of evolution of technology, and we're seeing, we've seen it come out of the universities. We're seeing products and services develop now, and I think it is kind of where we expect it to be. So I think for MPC and other techniques, the future's bright, and we're seeing more adoption of it across the industry.
Well, we love hearing that at the MPC Alliance, obviously. So thank you for sharing, and good luck. We need more of these collaborative efforts, which we'll talk about here in a little bit as well. Kurt, I know at Partisia Blockchain, you guys are working with a lot of folks on some pretty cool applications, and would love to hear more.
Yeah, absolutely. Yes, so I very much agree with the panelists, and so we've basically been focusing on building for the past 4 years a platform that is taking all of the challenges that we have met in terms of selling MPC and having people to adopt this technology, put that into a single platform, and this is live now in the third version, and these are 3 examples of applications that recently came into the project. So this is an independent project that come in and build applications, and we help them develop these applications. So the first one is called Better Internet Search. It's all about privacy preserving searching, a search machine. So here we have that the user is in control of data, and in an advertisement context, you convert that specific context into a persona, which is sent to the auctioneering of this person, and the winner is going to show an advertisement like we know in the advertising market. But here the users is in control, and the fair share of the profit that is generated goes back to the user. Another completely different use case is with the Cyber Peace Institute, where we are facilitating intelligence sharing of cyber breaches, indicators of compromises, which is a standardized way of measuring indications of compromise or cyber breach. And this is shared immediately among the good guys in the network. So you do it without sort of compromising your reputation or showing that you are in a weak position. So so everyone can be better prepared for what is coming. The last one I want to mention is another one just started up with International Committee of Red Cross, which is all about moving a cryptographic stablecoin into crisis zone. And the critical thing here is that the end users is going to be completely anonymous. So you end up sending money to a person, and you need to make sure that that person is receiving that in an anonymous way. Otherwise, they become kind of a target in the economy. And then you have to create a token economy that is also working with the existing financial system and is transparent and fulfill all of the regulatory requirements. So that's just 3 examples of projects that we are building on at the moment.
I know that you have many more to share, so hopefully in the future we can reconvene the panel and discuss it. But these are great examples of MPC for good, and it kind of brings us in maybe to a second round of questions that you've each brought up very novel ideas and applications. Let's talk about the bottlenecks. What is challenging us right now, and what can we do, probably more importantly, collectively, to accelerate and incentivize the use of MPC for individual, organizational, and societal benefit? Mark, you talked about some of your collaborative efforts with the UN. Where do you think we need to focus as an industry right now?
So I think I use those kind of Wardy mapping techniques to understand the evolution of technology, and kind of MPC and other techniques are kind of evolving as expected. But at the UN, we produced a handbook on, including MPC on pets. And if you look at that, there's some, quite explanations of where we think we are, where we're going, where the techniques and technologies are, and those kind of evolution of those technologies. And I think, we did that about 3 years ago, and I think, it's evolving as expected. Yeah. So I don't know if we can get a link to the book. It's an open free book. But I think what we really need to do is encourage competition in the market. And there's 3 types of competition. So conflict, collaboration, and cooperation. I don't think conflict is the one we need to focus on, but collaboration and cooperation are. And the way to do that is we can use open source, open data, and open APIs, open processes, and use that really as a weapon. Use open source as a weapon, encourage development, encourage sharing, and kind of encourage the kind of development of these techniques, and and kind of move MPC from more of a kind of evolutionary phase, from like the Genesis phase into those kind of products and services. And we're seeing that now. We're seeing. So when I started looking at 4 years ago at the UN, it was quite new and novel. That MPC, and I think now over the last 4 years we've seen more competition. We've seen more governments putting money into this to support the development, and now we're seeing products and services kind of evolving around MPC. So I think I think we're in a good shape, but it just takes time for these things to evolve. And I think as a group we get a bit impatient sometimes, because we expect everybody to understand this, everybody to be using this, and why aren't we all using this now? But it takes a long time for markets to catch up and to understand this and to develop it. But I think there's lots of opportunity where we need to focus on people with maybe the funds and the money to use these kind of techniques and support the development. So the military, the governments. I'm not sure the private sector are really the market for it at the moment, but maybe I'm wrong. But I think the government and the military are and space. There's lots of opportunity there. So I think we're kind of in a good shape. It's evolving as expected. And I'd recommend going and have a look at that handbook we produced about 3 years ago as part of the UN.
I find it, interesting and perhaps serendipitously ironic that the, achievement of competition through collaboration and cooperation can uniquely be achieved through MPC, right? So maybe we can find a path through the technology itself to enable that. Awesome. Well, Dan, you have a pretty unique perspective in the world, from the deep research into the industry applications. What can we do better together?
Since I'm the educator in the crowd, I'm going to talk about education and awareness. So I'll say that like what MPC does is kind of magic, right? If you pick a random developer, if you pick a random policymaker, a random regulator, that what MPC does seems impossible. Like many of them don't quite know yet that these capabilities are available to us. If we zoom out just a little bit, really, in some sense, what a lot of policymakers and even developers are trying to reconcile is the tension between privacy and utility, right? There's this feeling out there that if you're going to have utility from the data, you have to violate people's privacy. And if you want to preserve people's privacy, then you can't have utility from the data. It's like there's this feeling out there that it's one or the other. And you see this discussion over and over and over again among policymakers and even among developers and regulators, right? That it's a choice. You can either have utility or privacy. The magic of MPC is it kind of lets us have both, right? We can have utility of the data. We can run data analysis algorithms on the data and still keep the data private. And what is, I think, holding back the application of MPC is the fact that not enough people understand that this is possible. Yeah, it simply is possible. It's a reality. And I think there's a lot more education and awareness that needs to be made in the world. So we have to educate all congressional staffers. We have to educate policymakers. And honestly, we have to also educate developers that this is actually a tool that's available to them. And it's something that they can use. So, I guess it's on me to kind of, or on, hopefully on all of us to build the relevant educational materials. But I think until the world understands that this is a technology that's mature and it's ready to be deployed, we're not going to see massive adoption. So this is a big hurdle that we all have to get over.
Yeah. And, I think as practitioners, for all of us and much of the audience, we often get myopic and think everyone understands that we don't have to choose between this false dichotomy of privacy and utility with MPC, but it is not self-evident. You're absolutely right. The magic that you speak of has to be dispelled. So Kurt, what is the new magic, the way that we can dispel this magic into the world?
Yes, so building on the insights from Dan, and I can only recognize that this is kind of what we have to do every time we talk to new people who want to build on using MPC, that we try to explain that you can have both, but then they come back again and say, who holds the data anyway? I mean, you keep going back to that, so it simply takes time because there's something counterintuitive in this technology. So that teaching part is really, really important. With that in place, I think we're focusing on three things. One is to simplify the use of MPC. The other one is actually to minimize the use of MPC. And the third one is to talk about this in concrete applications, because that's our experience. That's where people really realize where the value added is, where the abstract properties of the infrastructure is mostly for the few. So in terms of simplifying the use, that's all of what this particular blockchain or MPC as a service is all about. So we are taking this to the extreme. So we have this incentivized economic system where you have computers, node operators that are running MPC. So you simply come into a network where everything is in place. You have the protocols in place. You have a smart contract language that makes it simple for you to articulate what do you want to have public, what do you want to have private. So you can have these, you can actually fulfill the entire sort of data directive of the EU. So you can have full transparency about the algorithms. What are you using data? How are you using data? And then you can compute directly on the encrypted or private data. So that's what this is really about, simplifying that and make it easy and accessible for smaller jobs, tons of millions of small computations, because that's what we believe is the real driver in the data economy. If MPC is going to make a big change, you need to have it out there ready to run whenever you need it. The other thing is to minimize the use. So you want to focus on on having a scalable solution and use the tool in the privacy preserving toolbox So it could be like Mariana was talking about, doing something preparatory. Maybe you don't need to bring it into an MPC system. You can maybe run part of the computation locally with the users, or and the rest you can, or maybe you just need to pre-process data or whatever. You sort of find sort of the minimal use of MPCs. That's typical the process when we have a new project. How do we solve the biggest problem with least use of MPC? And then when it comes to the concrete application, I think it's really about the focusing on the most, where we add the most value. And since it is this magic magic technology where you can work on data and you can have privacy at the same time, it's really where you go across existing boundaries. So it's about taking what you think is existing needed rent seekers or intermediates in the economy and find solution on how to replace them. Find these situations where you have competing companies that cannot share data and focus on that, or find other ways to sort of use the technology to bring back the control of data to the end users. Those are kind of big use cases where you really add values. So it's not just about solving for privacy, it's actually to solve something where you create extra value, and you can return that to the people that sort of solve this problem. And that's probably going to be the real driver at the end of the day, and not just going and solve for privacy, but generate value.
And I think we also need to be aware, we often talk about privacy preserving computing, but we see a lot of applications that are confidentiality preserving or proprietary preserving. So it is, what is it that you're protecting? And PII comes to the fore just because of the consumer sentiment and is in the public eye, but it's not exclusively pertains to that. Mariana, as you guys are developing these applications and putting them out in the wild, what are some of the inhibitors and what are some of the catalysts that you see that we need to develop?
So I think when you're developing products often like to follow standards, especially if these products need to be interoperational with other companies, with other players. So I think putting in place some standards around MPC, or at least some guidelines, will be very useful. And I think some of this work is already happening. For example, there is a community working group in W3C, which is focusing on privacy preserving advertising. And there is, and trying to come up with a common set of suggestions for measurement APIs in the context of web advertising. And I think it's very important, if you want to have something that's working across all browsers or all mobile phone platforms, that there's some standard that we can start from. And I think one more point is related to education. I think we also need to educate the user. My dream is that nowadays every user knows what encryption brings to them as value, even though I'm sure nobody knows what how the encryption algorithms work. So my dream is that at some point users will know what MPC brings to them, even though they don't understand the underlying mathematics and cryptography.
At some point, they have to trust the math, right?
I mean, yeah, but there needs to be this awareness that these are the properties that this technology brings, and there have been sufficient number of scientists and like engineers that have worked to back this up.
Great. Sanjay, not to leave you out on this conversation, I know you have a lot of thoughts on what do we need to do? Because again, think of the MPC Alliance and its collective over 50 members, of which Meta is a member. What do we need to do together to make this happen?
Yeah, I mean, I can go on. How much time do we have? But to keep it short, right? Like I think two high-level points. I think Mark already touched on some thoughts on open sourcing. I think it's really important. So I think we started working on the cryptography, privacy enhancing methods within the advertising space maybe like 4 or 5 years ago. And I think the first realization was, hey, like, it doesn't matter if like one company like builds all of this thing and like it doesn't really provide value. Like privacy is something we have to be able to like openly talk about how it works. A lot of different constituents need to actually understand. So I think like we pivoted very early on that like open sourcing, like we need to publish everything that we work on. We need to have, work with academia, work with other companies on like, how good or like how correct some of the things that we're working on, as well as open, not just like publish, but like try and open source everything you build. So like one example is we've been working on this effort called private computation, which is like allowing businesses to work together, on data that they each have. So like as part of building the product, we also said like what should be open source, like what framework should be open source, so that like companies can like work with us directly without having to hire cryptographers. Again, like you shouldn't require that like every company that wants to do this has to hire cryptographers to like integrate into a solution. How do we like build frameworks and open source them so that like everyone can integrate with ease? So I think that's something that we've been thinking about, and I think like this group and like a variety of other groups like Mariana mentioned at the W3C can help open source and standardize how some of these things work. So the second point I think touches on education. I take a slightly different lens, right? I think education to users is one. Companies that are using it is one. I think Dan mentioned regulators and policymakers as well. I'd add lawyers to that mix. So one of the early on frustrations, I mean, like growing pains, is that the whole idea of like using MPC is supposed to reduce the amount of contractual burden, right? So you have a bunch of contracts that say like, you won't do this, I won't do this, etc. So the idea is like when you use MPC, it like reduces the number of contractual guarantees you need to provide. But then we realized that that's not the case. Like early on, like Dan said, lawyers don't fully understand how MPC works, how it protects. I think when they see it at face value, so you're actually giving your data to all of these other parties. That means we need to protect all of that in additional contractual, language. So that was interesting takeaway that there's still a lot of work to do to kind of like catch up the non-technical aspects of MPC, like legal policy and regulation, to figure out like how to make it simpler and easier to kind of write contracts between two companies operating an MPC. The other aspect of it is, and I think like one thing that will definitely help here is I'd love to see some type of like an evaluation framework that's maybe standardized or advocated by either regulators or some maybe the MPC Alliance, where we're able to like show how different like technologies provide different guarantees. I think it's easy to say. I mean, I know you're going to talk about other types of technologies as well. But we need some place to show that, hey, like given this is what we need to do to protect personal or, for personal data protection, how can MPC provide like a superior guarantee versus something else that you could do, right? And I think there are methods right now, but they're so scattered that it's hard to kind of like have a source of truth to say, hey, I use this evaluation framework, and based on this, I can show that, this particular methodology or technique is better than this other thing. And it's really hard to kind of get like adoption and advocate for it if there's no common kind of frameworks to talk about.
Absolutely. I think on a positive note, there's a good trend in the policy and legislative sector to increase awareness and education in pets. I mean, we see the US-UK Pets Challenge now ongoing. We saw the ACPR at the Banque de France earlier last month. So, and the IAPP Privacy Security Risk Conference is in Austin in 2 weeks, and it has a list of policy folks, various departments in the US and other governments. So they are aware because they see that it achieves what they want to do, being able to use the data that they need with the privacy protections in place. But to your point of that framework of what are the guarantees that can be offered, there's a lot more work to be done there for sure. So we've talked about some pretty cool applications so far, but I feel like there's a few still on the edge or other areas that are left unexplored. Dan, you've been working on the core cryptography and software enablement for 30 years now, but you're also aware of how MPC can complement secure hardware solutions. So what are your thoughts there of how they play together, or do they?
Sure. Yeah. Maybe I'll make 2 points here. So the first one is if we zoom out just for a second, what we're actually trying to achieve is what's called confidential computing, which is how to compute on data without actually looking at the data. And there are sort of 3 approaches to confidential computing, right? One is using hardware enclaves, one is using MPC, and one is using fully homomorphic encryption, FHE, right? These are kind of 3, in some sense, competing approaches. And it's interesting that they're based on different assumptions, right? Enclaves are based on the security of the hardware. MPC is based on an assumption of non-collusion, and FHE is based on an assumption of keeping the decryption key secret. So they're kind of based on somewhat different assumptions. What's interesting is we can combine, for example, MPC and enclaves to get the best of both worlds, right? So imagine that we need to run an MPC computation, but say the 3 or 4 or 5 or even 10 servers that run the computation, imagine themselves, they are running on inside of an enclave. So we can get the benefits. We can basically use the hardware enclave to enforce the non-collusion that MPC needs. And at the same time, we don't have to fully rely on the enclaves because, of course, if you just do the entire computation on a single enclave, a compromise of the enclave would leak away all your data. So by combining enclaves with MPC, we make it so that even if 1 or 2 or a few of the enclaves are broken, the data is not harmed and not exposed at all. Yeah, so I think enclaves and MPC actually play really well together, and there's probably a lot more to explore there. That's one point. The other point I wanted to quickly make is maybe this is a bit further out, but I just love saying it. So
I'll say it as far to the end as you can go.
Yeah, exactly. So this is a bit far out, so bear with me. So I personally believe like the next decade or two is when we start seeing, the massive deployment of infrastructure in space, sort of further away from home. And this has implications to cryptography, right? I mean, so if we start to build a moon base, or maybe one day we'll build a Mars base, right? So now every round trip to the moon, a round trip to the moon takes 3 seconds, right? A round trip to Mars, depending on time of year, can take many tens of minutes. Yeah, and so now all of a sudden, if you have cryptographic protocols that take multiple rounds to complete, those are just going to become impractical. Even TLS, the multiple handshake round trips to do a TLS handshake is going to be problematic. Not to mention multi-round MPCs that are going to be problematic. So I think there's a need to develop, or there's a developing area which we could call cryptography in space, which is basically cryptographic protocols that are designed for extremely ultra high latency networks. Yeah, and traditional MPC, not traditional MPC, some MPC protocols are not very well suited for this because they require lots and lots of round trips. Some MPC protocols, in particular the ones based on FHE or even the Yao methods, they require relatively few round trips, and so they would be better suited for those kind of environments. So I think there's in the next decade or two, we're going to be seeing, hopefully MPC in space, and that would further constrain, or actually, I would say, lead the way to new research on new MPC protocols in these constrained environments.
Yeah, thank you for bringing that to light, because I don't think a lot of people are, they're focused on the on-Earth terrestrial applications, but definitely as we get into these higher latency networks, there's a lot of new challenges to solve. Unfortunately, we're running out of time, but Sanjay, I know you have some thoughts on this topic, so I want to give you the floor and respond here to Dan and what he's seeing as this future.
Oh, so I mean, it's fascinating to think about cryptography in space and the communication. Although I think I was thinking more cryptography on Earth and address one of the things that Dan was mentioning, which is around high latency and multiple rounds. So I think one of the things that we've also been thinking is, as the space matures and there are more and more use cases and more applications with MPC, there's likely going to be incentives to lay fiber, right? Would it be intercontinental, within a country, within a continent, etc., that could significantly, drastically reduce the communication cost. So that's one way to also think about it, where this kind of goes in the opposite direction that Dan mentioned. But for some applications, it could make sense to focus more on the compute and say, okay, eventually we're going to bring down the communication cost by laying down fiber. But I don't know when that is and how many years that will take, but that was an interesting way to think about it.
Great. We just need the better infrastructure, right? I mean, this really talks to your opening point, Sanjay, about this becoming an invisible layer. It's just built into the infrastructure, right? And that's really how we operate at scale. So unfortunately, we are at time for the panel. I would love to continue this for the next couple of weeks, but maybe we can bring you all back in the next series of the MPC Data Privacy Summit. So thank you all for your time. We've heard some great insights about emerging MPC applications, and perhaps more importantly, what we can do collectively to incentivize and accelerate adoption for economic and societal benefit. I think there's a lot of opportunities out there. We're just scratching the surface. So maybe a concluding statement, we talked about the magic of MPC. It makes me think of the words of Arthur C. Clarke that any sufficiently advanced technology is indistinguishable from magic. So let's dispel that magic and get out there and get it done. So thank you all for joining. Thank you, the audience, and we'll talk to you.